MathCounts has a team round where you are in a team of up to 4 people. And they also have a countdown round, which is kind of like game show buzzers and stuff like that, where you go head to head against people. Um, and then the AMC 8 is 25 questions. I'm trying to remember if it's like 50 minutes or an hour or something like this. 40 minutes. Apparently everyone knows in the chat. So the AMC 8 didn't exist when I was younger. But yeah, so 40 minutes to do things. So the key difference, I think, like the sprint tests and MathCounts and the AMC 8s look a little bit similar, in my opinion. The big difference that I put the chapter sprint rounds a little bit easier than the AMC 8, and then the AMC 8 probably is a little bit easier than the state level MathCount sprint. That's just kind of like my rough feel, but like they all can kind of look about the same. And with these problems, they start out with easier questions, and then the last question, question 30, is usually really, really, really hard. So this is kind of one of those things that if you're trying to spend your time and kind of depending on how you do on some practice tests, like figuring out like, I really need to just get the first 10, that's cool. I really need to get the first 5. Or if you're trying to like get all the way through the test, that's awesome too. The one thing to note though is question 30 is worth the same as question 1. And so oftentimes like talking to people at the state contest, people like they use the word silly a question. So they might silly question 1 where they're just trying, it's so easy. I'm going to do it so fast. And then they write an answer and they get that question wrong, even though they spent 5 minutes to get question 30 right. So that's kind of one of those things to think about. Also, if you have extra time at the end of the test, really making sure those first 10 questions are correct are important because again, every single question is worth the same. Then in MathCounts, the weird thing is like with tiebreakers at most sites, if you have the same number, technically they're the same, but 30 is worth more than 1. Yes. So someone's pointing out the tiebreaker rules in the chat, and that's what I was going to say next. So like if you both get 28 points or something like this, then the tiebreaker rules are they start looking at who solved the highest problem. So there can be some advantage of having the higher number question, but you just want to make sure you get those earlier ones correct. Tiebreaker is like, so a lot of times on these tests, you have people who have the same score and they actually come in with a ranking. So they say, who are the top 12 or who are the top 10 people at this contest because they get to do this like buzzer round, right? And so with that, I mean, one year, I think positions like 5 through 10, they all had the same score. So person 5 was the one who had like the highest number question correct, but they actually got the same number of points on the test. So sometimes in these things, you still need to figure out who won the test. And then they go to these like tiebreaker rules, which are, things like who got the highest number problem. But my point is just make sure to try to do your best on questions 1 through 10 because those are usually the most accessible. Okay, so we're going to start doing some problems. And the key difference between MathCounts and the AMC 8 is the AMC 8 is a multiple choice test. They're going to give you, 5 A, B, C, D, E, and you click it. If you're on an iPad, you're going to click it. If you're on a Scantron, you're going to fill in the box. Whereas MathCounts, they want their answers as a number and they want it in a particular form. So if they ask you for it as a fraction and you give it as a decimal, they'll mark it wrong. If they ask it as, for it as a decimal and you give them as a fraction, they mark it wrong. Someone says you're not really going to guess it right usually. Yeah, on question 30, you're not going to usually guess it right. So the AMC 8 and MathCounts also, there's no real punishment for guessing. So you probably should have an answer for everything. So if you're taking the AMC 8, AC/DC or whatever you want to do, you can kind of rock some guesses or, hey, I think this is going to be a test where C is a popular answer. So if you have some things that are blank, and as someone's pointing out, the AMC 10 and 12 do actually punish you for getting things wrong versus leaving it blank. But we're primarily focused on the AMC 8 and MathCounts here. So let's look at some problems. And I'll give everyone a little bit of time as we do these, and then we'll work through them. Maybe we can do kind of a cluster of problems at a time, and I can give you a few minutes. I'm kind of expecting a lot of answers, so I'm probably going to more reply to questions people might put in the chat than as opposed to answers today. But if I see numbers a little bit off, I'll try to give comments in the chat as much as I can. Seeing quite a few answers for a lot of questions, so maybe we can start talking about them. But if you want to kind of work on things on your own, just mute or just kind of turn your volume down. So question one, so with the sprint round and math counts, you don't have a calculator. With the target round, you do. So if we're looking at this, you got to think about what 3 to the power 4 is. So, oh, uh, so if we look at this, um, yeah, 3 to the power 4 is the same thing as 9 squared. So this is 81. 2 times 4 squared is 2 times 16. Uh, I had whiteboards off. Um, right. So we get 32, and so we get 49. So I'm not sure. I think I have whiteboards off, but I'm seeing things on the screen. Okay. So for this next one, you can write out what these numbers are. You have 4,326,052. You're subtracting 4,325,131. So if you're to do this and you start doing the subtraction, you get 1, get 2. We would need to carry over here, and then everything else is going to cancel out. So we just get 921. Okay. And last but not least, like with a problem like this with the median of the data set, you just got to order it. Yeah, so some people in the chat are giving me some so one thing like let's not write on the screen. For some reason I'm not seeing an option for disabling that. Disabling screen annotation. Um I think because I'm screen sharing from like a second computer, so I think I have to have some options open for that. So okay, so the median of the data set is 0. So we start writing things out 0, 3, then we have 4, 7, 8, yeah, 11, and a 16. And so it looks like we have 7 numbers. So the median is going to be the one where we're going to be in the middle, and we do get 7. Is this okay? Alrighty. So let's do a few more problems. Does anyone have any questions about how we did these 3? So usually the first 3 are the more direct ones. That doesn't mean that they're easy or anything like this, but they just kind of have you do some computations. Okay. Here's another 2 problems. Okay, so someone's asking, how do we start problem 5? So, so let's do question 4 first, and then we'll start question 5. I can give people a little more time first, though. But for question 5, so it seems that you can choose any particular 2-digit number. So what you might want to do is pick a number which is really, really easy to work with compared to other numbers. So for instance, 10 might be a really good number to start with. So if you're kind of not sure how to start problem 5, what is the easiest 2-digit number I could work with? It's probably going to be 10. Someone's pointing out in the chat. If something's asking for the result of an algorithm and it lets you choose whatever the starting point is, that generally means that it's not going to matter what you start with. So you just want to kind of start with the thing that's going to make the process the easiest. Okay. Alrighty. So we can start talking about 4. So Parker and his 3 being if Parker got 11 pieces of candy. So Parker is going to get 11. And his friends each got twice as much candy as him, but they're 3 friends. How many pieces of candy did Parker and his friends get in total? So if we think about this, so each one of Parker's friends is going to get twice as much. So they're going to get 22 pieces each. And there's 3 friends. So the number of friends times the amount of candy that they're going to get, which is 22. And you get 11 plus 66, and you get 77. So for this next one, I mean, again, you're going to get the same answer no matter what you start with, but the process can be a lot more clunky if you start with a bat like a if you start with my favorite number is 73 or something like this might actually be kind of a painful thing. Because if you look at it, the next step after you pick your two-digit number is you need to multiply it by 153. So what's the nicest thing I can multiply by 153 that's a two-digit number? I'm going to start with 10. And if I multiply it by 153, I'm going to get 1,530. Then I add the digits of the number that I get. I get 9. And so it says if the sum resulting from step 3 has more than one digits, repeat step 9. So this is actually that am I divisible by 9 trick that we saw when we did our number theory lesson. But we are a one-digit number, and we can just stop at 9. Can you pick any? Yeah, so actually with this, you should be able to pick any two-digit number. It's just this step 2 is going to be much more painful if we started with the number 77 or something like that, because we'd have to multiply 77 by 153 and we don't have a calculator. So sometimes if they give you a process and they give you the flexibility of picking the starting point, you might just want to say, well, what's the easiest number I can put in with respect to like carrying out the rest of the steps. So that's kind of like a good game plan. Yeah, so someone has a question about question 4. So yeah, Parker and his 3 friends, so there'll be a total of 4 people. So yeah, so I saw some answers where it was like if Parker and his 2 friends or Parker in a group of is it part of a group of 3 question people, then yeah, you would get a slightly different answer. But here, Parker, it's going to be Parker and then 3 other people. Okay, any other questions about 4 or 5? So someone's asking about calculators. So in math counts, you can use calculators on the target and team rounds. On the sprint round, you can't use calculators. So usually at the start, the calculations are things you can kind of do on paper or maybe even in your head. But once you get to questions like 29 and 30, sometimes, like I'll be honest, you wish you had a calculator because the mental arithmetic can be pretty bad. Is it time? Yes. So on this particular test, there's 30 questions and you get 40 minutes. Okay. So someone asked in sprint rounds, they mark the questions wrong. Yeah. So what they really are doing is they tally up your number of correct answers. So you're going to get some score between 0 and 30. So when I took tests when I was younger, like questions like 6 would always bother me because like I'd always kind of do something silly when I do them. Um, uh, yes. So we are including the Clover room in number 6. So for doing this, we got all these directions, right? And you got to kind of think, I'm walking this way, I go straight and I turn right. So if I'm kind of going this way and I turn right, I'm going to end up here. And if I'm going down, right to me at that thing would be going here. If I'm going this way, turning left would be going this down here. If I'm going downward here, right, red's a little better, then turning left would be here. I'd go straight, straight, straight. And if I'm going in this direction, going right, I go down. As I go downward, going right, I go this way. If I'm going this way, turning left would mean I go this way. And then I turn left, which would mean I go this way and this way. So if you kind of count the total number of boxes you use, you're going to get a total of 13. So these ones, in my opinion, are really just easy to make like a really minor mistake and be off by 1. So, but they have that kind of spatial, like if I'm walking in this direction, I turn. And I think nowadays, like we use maps a lot less than we used to because our phones do everything or your parents or guardians' phones do a lot of things. So like, back in the day when you're just looking at a giant map, you had to think, am I turning left or I turn right when these 2 freeways are going to be intersecting and stuff like this. So it's maybe a little trickier question than used to be because of like our use of technology. Okay, so the sum of an integer n and 18 is equal to the product of 4 and 5. So as you kind of move through these tests, like you're going to see more algebra come up in the higher number questions. So math counts, technically is on seventh, eighth, and seventh, eighth, and accelerated eighth, which oftentimes is like high school algebra one. Those are kind of like the fair game topics. And so, depending on where you are with respect to your algebra journey, some of these questions could be a little bit tricky. So the sum of an integer n and 18, so that means n plus 18 is equal to the product of 4 and 5. So the product of 4 and 5 is 4 times 5. So we have an n plus 18 is equal to 20. Now, if I have an equation, what I do to the left, I need to do to the right. So I'm going to subtract 18 from both sides, and I'd find that n is equal to 2. And with some of these problems, like, you might be able to guess and check too. I mean, if you have some kind of feel, you might be able to say, oh, this number is too low, so I'm going to try a bigger number. Oh, that gives me too big of a number. You might be able to just kind of guess here for things of what's going to work. Someone said problem 5. So was there a question about problem 5? Oh, yes. Okay. What's the question about problem 5? Or is there a question, or do we just want to look at it again?
So I want to look at it again as I got confused from that problem.
Okay. I'll leave it up for a second. I can also put the PDF file in the chat if anyone wants it. So then, it's because we probably won't get through all 30 questions today. So if anyone ever kind of wants to look at this later, um, we can do that. A lot of these tests you can find online, and I sent your parents and guardians like a web page that has like 20 years of math counts contests. So you can kind of get a lot of these things if you want. Yeah. As people pointed out, I started drawing the wrong shape because I misread the question, but um, strangely, it doesn't change the answer. But yeah, so the rectangular prism basically just looks like a giant box. I misread it and thought it, no, said we kind of had the shape that was going to be kind of like more of a pyramid thing. But alrighty, I'm seeing some answers. Oh, question. Okay. You can start doing some of these. I see some people are jumping ahead with the PDF. So let's just kind of focus on the ones that we have here. So, okay, so this question 8, we have this, yeah, adjacent means like you're right next to someone. So okay, so let's look at this question 8. So more than 100 students sign up to participate in a geography bowl. Teams of 2 could be made with new students left out. This is saying that the number of students is going to be a multiple of 2. And teams of 3 could also be made without having a student left out. So we also need to be a multiple of 3. So if we have more than 100 students, so we have like uh, at least 101 students. So we got to ask ourselves, what is going to be a multiple of 2? So if we're thinking about this being a multiple of 2, you know, these are going to be multiples of 2. And if you're thinking about being a multiple of 3, well, because this is where we could just add the digits. So 101, if we add the digits, we get 2. So we are just going to get 102 here. And that's going to work. It's going to be the smallest number. So with this one, if we're thinking about things that are going to be multiples of 2 and 3, every 6 numbers would actually satisfy this. So you might be able to just kind of get, start listing things off and kind of go through the motions and check. All right, so this next problem, so Manuel wishes to paint each face of his rectangular prism so that no 2 adjacent faces of his prism are the same color. What is the minimum number of unique paint colors he needs? Like the bottom side yellow. We can see here that that's going to kind of force that I need to use another color just to hit any particular side. But the fact that I have 2 faces here that are also going to be adjacent means that I need to use 3 colors. But then if you think about it, can I just kind of continue this pattern? Yes, I can. So the top and the bottom can both be yellow, and then I could have kind of pairs of sides being green or say red. And so 3 colors would be enough. Okay. So we have the width of a rectangle is, okay, let's look at this one. So I see some answers in the chat for this one. So this is a pretty standard question for algebra, but it would not necessarily be something you would see a lot of before you take an algebra class. So the width of the rectangle is 1 longer than the length. So if I have a particular length, the width is going to be the length plus 1. So someone says, wait, I got 3 though? Yeah, so 3 colors should be enough on the last one. But you can't do it with 2 colors. Just if you kind of, I mean, like the easiest case of this would be thinking about a cube. And like, you wouldn't be able to 2 color a cube. Okay. Yeah, so people are coming up with some answers here. So you might be able to guess and check on this, but here we're given that the area is 72. The area is going to be the product of these 2 dimensions. Now, for those of you who have had a little bit of algebra, you could use a quadratic formula on this. You could factor. you might be able to just kind of guess and check. And guess and check would be probably faster here because if you're thinking about two consecutive numbers that multiply to give you 72, 8 and 9 are going to fit the bill. So this would be telling you that your L is equal to 8. So your L plus 1 is equal to 9 then. And then if you kind of do the perimeter, we have a 2 times 8 plus 2 times 9. And we would just get 16 plus 18, and you'd be at 34. Is that okay? Okay. So, I had a question, but it disappeared. Someone's asking for a little time. That's okay. So we can take so want a little time on question 10, because I might be able to kind of pull up question 10 and 11. If you have any questions, you can let us know. Someone's asking how to start number 11. So with these, the further we get into the test, the more they are going to, involve some things with algebra. So you might be able to guess and check, but at some point, like you might need to start setting up some equations. So I have a non-zero number of goats. Goats have 4 legs, and I have a non-zero number of chickens. Those have 2 legs, are going to be on this farm. And then we have 3/8 as many heads as there are legs. So if you're trying to set this up with equations, you might need to figure out, how many legs do I have to get going? I have 4 times, the number of goats plus 2 times the number of chickens. That would be my number of legs here. Now, it's given that, you need to have 3/8 as many heads as there are legs. So if I'm thinking about the number of heads I have here, well, each goat has a head and each chicken has a head. So how do I relate these two things? I have 3/8 as many heads as I have legs. So 3/8 times the number of legs is going to give me the same thing as the number of heads. Okay, so this is, something you might be able to guess and check this because the final answer is actually a pretty low number. But you might, try to solve this. If you want to just kind of systematically do this, we could multiply both sides by 8. And if I distribute it into 3, I get 12 goats plus 6 chickens. And I have this equation relating these things. I could subtract 8 goats from both sides, leaving me with 4 goats over here on the left and 0 goats on the right. And I could subtract 6 chickens from both sides, leaving me just with 2 chickens. So then that means that 2 times the number of goats is going to be equal to the number of chickens. And so we know that both of these things need to be non-zero. So what's the smallest thing that I could put in and actually make this work? The smallest thing I could put in is having G equaling 1, which would force C to be 2. So your smallest number of chickens that would be possible would be 2. So this one is a little bit trickier if you're kind of thinking about all the algebra to it. You might be able to kind of guess and check or just kind of, well, what if I had 2 chickens and how many goats would I need to have? Or what if I have 1 chicken, how many goats do I need to have? And things like this. And try to, if you know the answer, if you're looking for the smallest ones, you might be able to rule out having 1 chicken and then having 2 chickens is going to work. But there is a systematic way you can do this with algebra, but I know not all of us have had an algebra class yet. Okay. This next one, I kind of put in it's just a really long question on a speed test. So with this, you get 40 minutes to do 30 questions, and it almost takes a minute to read this question, which I don't always love that, but they do that a lot. So we have these 7 judges. They're going to rate someone, and we have a level of difficulty of the dive, and we discard the 2 lowest and the 2 highest. So they give us a particular level of difficulty. For this one, they said level of difficulty is 3.5. And then you're going to need to multiply that 3.5 by effectively the middle three scores. So they say that out of these 7 scores, we eliminate the smallest 2 and the biggest 2. So what are the smallest 2 here? Well, we have 2 scores that are down at 7. We have the biggest score is 8.5, and then the next biggest score is 8. And there's a kind of a two-way tie for that, but we could eliminate one of those. So it looks like we have 2 people gave a 7.5. And we have 1 person also gave an 8. So this is also where it gets a little bit messier when you don't have a calculator. Because if you don't have a calculator, you have to do all this arithmetic in your head. So 2 times 7.5 is 15. So we would get 23 for this. And then we have to multiply this. So if we have a 3 times 23, 3 times 23 is going to be 69. And 0.5 times 23 is going to be 11.5. And so we'd end up with 80.5 when we do this. So just one thing to kind of note, whenever we're writing on the screen, everyone's actually seeing this. So I apparently can't disable the screen annotation without disabling the screen share. So, okay. But as we go further into the test, these questions either get trickier with respect to like the arithmetic involved or with respect to the concepts involved. And we're really starting to see, okay, I can leave 12 up for a little bit. People still want to do this, but let's work on 13. Seeing a lot of answers for 13. So one thing we want to think about is the original recipe was for 24 cookies, and this one says we want to make exactly 18. So if we're kind of thinking about, what fraction of a full batch are we making, we're going to be making 3/4 of a batch. And so we're given that this cookie recipe calls for 1 3/4 cups of sugar. So we need 3/4 of that in order to make just 18 cookies instead of 24. So mixed fractions are always kind of a little annoying. So sometimes for me, I find it a little easier to work with things if I convert it to just a regular fraction, like an improper fraction. So 1 3/4 is the same thing as 7/4. And so this is going to say that we'd be at 21 divided by 16. And then, so an important thing is it says, express your answer as a mixed number. And I don't particularly like this, but they will mark you wrong if you don't write your answer in the format that they actually ask you to write it. So if you take a 16 out of the 21, you get a 1, and what you're left with is 5/16. So this is just kind of like a really messy fraction problem. And again, like sometimes they actually add a lot of words, which can make things a little harder than just having kind of a very direct math question. So someone has asked, on 14, do they measure diagonally too? Yes, they actually will. So if you have people on kind of different corners of a rectangular room, you'd imagine that you have like a tape measure and you kind of go diagonally across if the 2 people are kind of kitty corner from each other. So if you're trying to have a minimum distance between Fyodor and Alyosha, you probably are going to have Fyodor and Alyosha be kind of on the same kind of side. So I have a question about the crates. Okay. The 64 crates of 144 calculators mean that there are 144 calculators in each crate. Yes. So each one of those crates has a bunch of calculators. Right. So as we look at this, I mean, we can see here that Dimitri is a little bit closer than Ivan. So maybe we put Dimitri here and Ivan here. But if we want Alyosha to be close, we don't want to put her across a diagonal because that's going to push her really far away. So if we're doing this, we see here that uh, Fyodor is 3 from Dimitri. And if we're kind of measuring the distance to Ivan, we are 5. And so this is a pretty nice thing because when we have a rectangle, we see that as we go across, we have right triangles. And so we might recognize that this is a 3, 4, 5 triangle. But you could also use the Pythagorean theorem to figure out the other side. But that would put 4 meters between Fyodor and Alyosha. So, okay. Okay, so and I'm seeing some answers for the calculator question. Give people a little time to work on that. Yes.
For number 14, doesn't it say that Dimitri is 5 meters from Ivan?
Yeah. So it actually, Fyodor is 3 meters from Dimitri. And then, so this and here is still about Fyodor.
Oh,
So yeah, I mean, some of these questions are also kind of worded in a way that or it can sometimes be a little bit hard to dissect what they actually mean. Like some of the really old math counts contests, if you go back to one of the websites I shared with your parents or guardians has like math counts tests back to I think like 95 or something like this. And some of the really old tests have some weird wordings where you're like, what are they actually getting at here? Can happen. Usually they're a little bit better about this in recent years. Okay. So I'm seeing more answers come in on 15. Oh, yes. Go ahead and ask your question.
So what does it mean by how many total calculators are expected to be defective?
So expected to like, so this word defective will mean like how many are kind of like broken calculators. So like if you went to Walmart and bought this calculator, you bring it home and it's telling you like 5 times 2 is 13, you'd be pretty upset. So like this is saying like how many are bad. And this is actually one of those things that people who work in factories, there's quality control people. And they're trying to figure out like, okay, it's okay if like 1 out of every 1,000 of our light bulbs don't turn on, but maybe it's really bad if 40 of those aren't going to turn on.
The defective means to be broken.
Yeah, it just doesn't work properly. Malfunctioning is another word that they might use.
Yeah.
So this quality control person is just checking things at random. Uh,
Boy.
so he's just going to check 12 calculators from each of the 64 crates. So he's going to check a total of 12 calculators from each of the 64 crates, and he found that 2 of those are going to be defective. So this is going to be, the fraction that we're going to get for like how many of these calculators are going to be defective. But then you want to kind of multiply this fraction here by how many calculators do you actually have? Well, we have 64 crates, and each crate has 144. So if we cancel off these 64, we're really left with 6 times 144. Okay, that's a little annoying. So maybe I divide in a 2 first. I have 1/3 times 72 and check my math. And 1/3 times 72 is going to be 24. And that, yep, is matching most of the answers I'm seeing. Is this okay? Let's maybe do a few more, and then I'll send into the chat again the PDF file just in case anyone wants to to look at this more because we won't get through all these things, but things also do kind of ramp up a little bit. So some of us might be kind of uncomfortable with questions in the 20s. So someone says, I could have canceled out a 12. Yeah, actually, that probably would have been better. I could have canceled off a 12 with a 144. And just like being able to do fast calculations, that's a good point. That's more clever and faster than what I did. What I did was just kind of like, oh, I canceled some things. But, sometimes that can make a difference if you can save some time for your calculations on later problems. And you can do a few more questions. Yes, go ahead.
So how do you start problem 16? Because
Okay.
it's saying, so the first sentence saying 75% of tickets were sold at the full price of $30.
Mm-hmm.
And then the remaining 25% was sold at a discounted price of $10.
Mm-hmm.
So do you have to find the average selling price for this one?
Yes. So, and you could
Yes.
like pick a particular number. One thing to note here is it doesn't tell you how many tickets were sold. But if we're kind of thinking about them, 3/4 of them would be sold at this price of 30, and 1/4 of them would be sold at this price of 10. So we could do just this so if we're kind of thinking about this, this would be effectively like one way to compute this, but you could also say that there's 100 tickets. If there's 100 tickets, then 75 would be sold at 30, 25 would be sold at 10, and then you need to add all that up and divide by 100. Or you could kind of do it this way. 3/4 of it have 30 as their number. 1/4 of it have 10 as their number. And so if you're trying to put this in fraction form, you get 25. And they say round it to the nearest cent. So let's say 25.00. Is that okay?
So, mm, so basically just multiply the 30 into 3/4 and then add it with 1/4 into 10.
Yes, that would be one way to do it.
And then you add the 90 and 10 divided by 4. Then you get 25. Okay.
Yeah. And another way you could do this is you could just suppose that there's 100 tickets. Oh, we got another question. Go.
Hi, could you have done it as there, like, I did it so that there were 4 tickets sold in total, which kind of goes with like your denominator.
Yeah,
I did it.
that's a really good idea. Yeah, that would be perfect. So you can always pick a particular number. If you did 4 tickets, then you have 3 tickets at 30 and 1 ticket at 10, and then you're dividing it by 4. And yeah, you'd get the same answer.
Hmm.
So you can always kind of set a particular number. Yep, that's a really good idea. Okay, so it's 11. So why don't we do one more? This I would put in they have an overly complicated question, but then they're going to make you do some annoying arithmetic. So for what it's worth. So they're like, they kind of ramp things up as they kind of go. And again, I did 100 tickets. Yeah, if you did 100 tickets on the last one, yeah, so you have 75 that look like one price and 25 look like the other price. That would work well. Yeah, so there's different ways you can do this. And one thing I just always want to note here is we don't always solve questions the same way. A lot of times, if you look at the art of problem solving, for instance, as you study an AMC 8 question, like you'll click on a question, maybe do the problem, you check your answer. Then when you check the solutions, they might have like 10 solutions for some of these questions. Like, so there's different routes you can do these problems. So yeah, so kind of finish up today with a terrible, a longly worded question with diagrams and messy dimensions. So out of all of this stuff here, yes.
So for number 17, do you have to find the area of all the like rooms, like the dining room, then masonry, kitchen, bedroom, and living room. Do you
Well,
find the area and then add them up all together?
well, here, like towards the end, it actually seems that they just want the dining room. So what they really want us to do, even though they have all this complication and wording, they really are asking us only to figure out what is the area of this one particular room.
Wait, so one way that you could do, so you could you just add all the rooms, like find the area and add the four rooms, kitchen, bedroom, living room, and masonry, and subtract the dining room?
You could if you knew what the overall area was, but here we don't. So if we just needed to know what the dining room area is, effectively, we just need to kind of multiply these two dimensions to find the area.
So we need to find only the dining room.
Only the dining room. But here, like sometimes they will make you do unit conversions, especially centimeters to meters and inches to feet are common features. Sometimes, you'll see some things with cups and ounces and things like that. But here, effectively, we need to multiply these two numbers, but they're a little bit annoying to do. And our final units are feet squared. So what I want to do is just convert these two numbers to feet.
But
Yes?
here it's saying that the dimensions of each room are given in feet and inches. So that means you convert feet to inches or inches to feet?
Yeah, let's convert them to feet.
Feet?
So 11 and 6 inches, well, 6 inches is half a foot, right?
Yeah.
So effectively, this first dimension is the same thing as 11 plus 1/2. I could write this as a mixed fraction. I could, improper fraction. I could write it like this. However we like doing this. The more annoying one is this 12 and 5 inches. So 12 feet and 5 inches is 5/12. So this is where if we had a calculator, this is easy to do. Without a calculator, it's a little tedious. Yeah, was there still a question or are we just working?
So since it's saying what's the area of the dining room of the Shelburne #1 model, so you just added the 11 plus the like half foot,
Yeah.
and then times the 12 plus the 5/12.
Yeah, because effectively this is the same thing as 12 feet 5 inches. This is the same thing as 11 feet 6 inches, right? So, but then when we multiply this out, it's a little bit frustrating. You could expand it out. So I have an 11 times a 12, which is 132. I have a 1/2 times a 12, which is going to give me a 6. That's not too bad. I have a 5/12 times 11, which is going to give me a 55 over 12. And then I have a 1/2 times 5/12. I'm getting some 0.000. I'm not sure. So we would get a 5 over 24. So this is a little bit ugly. And again, like the arithmetic they make you do is just going to get a little worse as you kind of go through the test. So like this is why, like, especially when we're getting started out MathCounts, like those first 5 questions, those are ones we want to be able to handle. But as you get more comfortable, the next 5, the next 5, the next 5. And sometimes you're just going to be like, if there's a geometry problem, maybe geometry isn't like, what we love, focusing then a little on number theory or something like this could be a good idea. Okay.
So I have a question.
Okay.
So for this problem, did you just add like the numbers first and then plus the fractions?
I
Like-
expanded it. So I have 11 times a 12. I have a 1/2 times a 12. I have to do the 11 times this 15 over 12. And I have this 1/2 times this 5 over 12. So if we're kind of expanding out patterns.
Wait, so this is kind of a little bit confusing because it's just like 11 plus 1/2 into like times the 12 plus 5/12.
Yeah,
just
so
wanted
everything
to
in this
know-
parentheses. So
I
we need to
just
kind of
wanted-
pair things up.
I just wanted to know how you got the 132 plus 6 and then added with 55/12 plus 5/24.
Yeah, so if I have numbers like this, so I have something plus something times something plus something, when I distribute, we're going to get this number times this number. We're going to get this number times this number. We are going to get this number times this number. And we're going to get this number times this number. So we're going to get 4 numbers, but if you want to put things into as a improper fraction, that'd be fine too. I mean, for instance, you could also do this problem as if I put this into a common fraction, it's a little bit messy. I could equivalently do this as so 11 is 22 over 2, so this is 23 over 2 times if I put this into an improper fraction.
So is the answer 13?
The final answer won't be 13, so I was still kind of in the middle of that calculation. But just another way that we could do this if we don't want to try to expand out things with the distributive property, we could put this into an improper fraction, so it'd be 149, and then you could kind of multiply if that's better. Sometimes like with improper fractions or mixed fractions, I like to just kind of break it up into 2 parts and then expand things out, because like if you have a calculator, this is really fast to do. It's just really kind of clunky to do without. Maybe this calculation is better without, but if I'm adding things up, we get 138. If I need to put these things under common denominators, I get 110 over 12, and I get or over 24, sorry. And I get a 5 over 24. So we'd get 138 plus 115 over 24. And they say that we want the answer to the nearest foot. So if we're kind of looking at this, yeah, we're going to have to round this. So, but if I look at this number here, 24 is going to go in 4 times. So I could pull out 4 of those. If I pull out 4 of those, I can be left with 17 over 24. And so 17 over 24 is closer to 1 than it is to 0. So we'd be rounding up to 143. So it's a little bit of a messy question. I'm not going to lie. Like as you go further down the line, like just the arithmetic gymnastics you need to do are going to get quite a bit worse. So what kind of makes this problem really hard, in my opinion. So is it 138 and yeah, you can maybe simplify the fraction. So with the final answer, we'll want it rounded to the nearest foot. So like if you have kind of like a fraction at the end, you might need to like round it up or round it down. So yeah, so these are tricky questions. Yeah, so when we have the kind of fraction, so someone is asking if their answer is correct. If we have a number, like an integer plus a fraction, but the fraction is an improper one where like the numerator is bigger than the denominator, you might need, in order to just kind of see what that thing would be, you might need to kind of take out the biggest integer you can from that and then kind of add.
So basically for this problem, you multiplied x times z, x times w, y times z, and y times w, and added them all together?
Yeah, that's effectively what I did. Just because like if I'm trying to do this multiplication, it's just really kind of hard to do like in one go. But if you did convert these things to improper fractions, you could do this. But at some point you're going to need to multiply 23 by 149. And then you're also going to need to be able to like figure out what the closest integer is to that.
Because
Right.
for this problem, I got a little bit confused.
Yeah, I mean, these do get trickier. So I'll be honest, like these things, like, when you start off with 1 and 2, they're gonna be a little bit
complex.
Yeah, like the earlier ones will be a little bit more doable and the later ones will be a little bit harder. So there are more questions here. So if anyone wants them, I can, in the chat, I can put in both the exam and the final solutions. again, your iPad, your computer, whatever you might not want to download PDFs or anything, but these are the official MathCounts ones. So if anyone wants them, you can have them. But like, because if you wanted to try the later number things, these don't have complete solutions written up, but if you search on the internet, there are complete solutions written up, probably. Yeah. So it's probably a good spot to stop. So what we'll do over the next few weeks is I want to just try to introduce you to the flavor of some of these tests. So we'll look at a target test, which is like a different kind of thing. We do 2 problems at a time. We'll look at an AMC8, which feels a lot like this, except there's multiple choice. And maybe we'll even do some countdown round stuff where we kind of just like, we need to answer fast.
So next week, we're going to finish this sprint round test.
Next week we'll do a different kind of test. So usually, like with this, I want to kind of start with the easier questions, but then when we get to the later questions, it does get a little bit more difficult. So these are things that if you want to work on them, you can kind of work on them. But we're going to do something different next week.
Okay.
Any other questions?
Nope.
Alrighty. Well, I'm going to wrap up this session, and I hope you all have a wonderful weekend.
Thank you. Bye.
Bye.
Thank you. Have a great day.
Yep, you too.